Okay, so let's take a look at number 83. You guys are all done with number 83, right? So 83 is 612 slope all around. We're asked to find J, Z, M, and R. Where did you start? The common, okay. So what did we do first there? Pardon me? 30-foot span and 612 slope. I did forget to put that in the main picture here that this is a 30-foot span. Still up there. There we go. So now what? Well, we got to take, this is H, our run is 15. So yes, 6 over 12 equals H over 15. And then cross multiply to divide and get 7.5. 7.5 feet. Then what? J is going to be found by doing the square root of 7.5 squared plus 15 squared. 56.25 plus 15, or plus 225. 281.25 to square rooted is what? $16.770 feet. Look good to everybody? Works for me. 771 actually. So 16.771. Then what? What's Z? Nope, Z is the same as the common. This is a conventional hip. Slopes are the same, so the longest jack is going to be the same as the common. So what's that mean? We are not asked to find this. What does that mean for our setback? Same as half the span, so that's 15 feet. The reason I needed to know that is to find R. This is 16.771 here. This is 15. How do we find R? Yeah, square root of 16.771 squared plus 15 squared. 22.5. And now to find M, we're given that this is 12 feet here to M. If you look out here on this triangle, we have 16.771 here, 15 here. M is going to be in here at 12 feet. So this is 12 feet. This is M. How do I find M? Perfect. 12 over 15 equals m over 16.771. Cross multiply and divide. 13.417. What do you think? Okay. Who had those 4 answers? Who had 4 answers? Who attempted the problem? Okay. Number 84. 612 main roof, 812 hip. 36-foot span. Asked once again to find J, Z, R, and this time M and N. Where M is in at 12 feet again. Where'd you start? Common. What do you know? Yeah, half the span's 18 feet. Looking for the height. Then what? Six over 12 equals h over 18, so that gives h is 9 feet. So J square root of 9 squared plus 18 squared. $21.125 or 20.125 feet. Does that mean Z is 20.125 feet? No, why not? Different slopes. But we do know what about, if this is Z here, what do we know about that? We know it's 812, very good. What else do we know about it? The height is 9 feet. So we have 8 over 12 equals 9 over, I'm going to call this S because that is the setback. So 12 times 9 is 108. Divided by 8 is what, 13 and a half, 13.5. So 13.5 foot setback. So we can find Z. Z is going to be the square root of 13.5 squared plus 9 squared. Otherwise known as 16.225. Now we can find R. How do we find R? One of two ways. I can use the setback of 13.5 and the common of 20.125, or I could use Z as 16.225 and half the span of 18. Both of them will give us the same number, at least within round-off errors. Should be 24.233. So R here, 24.233 feet. M, how do you find M? You know, this is 18 feet, 16.225. What do we know about M? 12 feet. So 12 over 18 equals M over 16.225. $10.817 is M. Now to find N, do you remember our trick for that? Z compared to M has to equal J compared to N. Now, of course, I left all these answers in decimal feet. I'm making the assumption you guys can turn them into feet, inches, and sixteenths. And I'll leave you guys to find that last one on your own. Any questions on these? So that should wrap up the hip rows. How many of you feel pretty confident about being able to find these pieces of the hip rough? How many feel like you'd rather run out of the room screaming and crying? Nobody raised their hand to that one. That's good. Every year I usually have one or two that admit to that. So, oh, I just want out. Let me go. Okay, so what we're going to talk about today, our new topic, is fascia matches. For fascia matches, what we're talking about is, of course, the overhang of a truss on a roof. And the fascia is mounted out on the end of that overhang. If I have two sections of the roof that have different slopes, or two sections of the roof that have different overhangs, or different wall heights, or whatever, on the outside of the house, it's preferable if those fascia heights match. So let's say I've got one part of the house here that has a 612 slope, and another part of the house over here that has a 1012 slope. Well, the wall height is going to be, if the wall height is the same, even though that 1012 slope has a higher heel, because it is a steeper slope, its fascia would be lower. Let's say these both have a 2-foot overhang. Well, this one, from here to here, is going to drop 12 inches. Why 12 inches? 6 inches per foot times 2, right? How far from here to here, how far is this one going to drop? 20 inches. So even if this heel is an inch or two higher, which it's going to be on a 10-12 slope, it'll actually be about 3/4 of an inch higher, this is still going to be 6-7 inches lower down here. We don't want that. When we build that roof, if you're looking into the valley of the house where the pieces come together here, you don't want to be have the fascia off this side of the house hitting here and the fascia off this side of the house hitting down here. You're going to have a step up in your roof or whatever there. That looks really horrible. It looks best if the fascias match. So we have options. The most common option is to adjust the heel height. So what we would do is we'd take this heel here and we'd raise it up so that this fascia here is at the same height as this one. Does that make sense? So there are 2 points that we know are going to be equal in these fascia matches. One is top of the wall. It's going to be the same. We're assuming the wall height is the same in both sections. We're adjusting for different slopes, not for different wall heights. The other thing we're going to assume is the same is wherever the top of the fascia is going to end up being the same. Make sense? So we've got a couple of examples that we're going to do. The first one, different slopes. Same overhang. OH stands for overhang. We're going to adjust heel height. So the heel is going to be adjusted. Now the drawings I put in your packet are very poorly done. And I'll show you why here in a second. In the packet, I drew them something like this so that these tails stopped above the wall height. In reality, those tails go down below the wall height. So we're just putting this wire frame in here like this. And what I'm going to give you, this is a 6/12 slope. This is a 10/12 slope. Which heel height is going to have to be adjusted to make these match? The 10/12 is going to have to be lifted. I can only push the 6/12 slope, that heel height down so far. I don't have a heel. So we're going to leave that 6/12 slope at what we call a type A or an energy heel. So this is going to be 6 3/8 inches for 6/12 slope. So we're going to have to raise the 10/12 sloped heel. We're going to have to raise that heel up higher than normal to make this work. Let's say we want our overhang to be the same all the way around. We want 18-inch overhangs on the whole house. We're going to try to figure out what's that heel have to be. What I need to know is how far are these tails below the top of the wall. So if I call the top of the wall here 0 inches in height, I've got to go up or down from there. So this is my 0 point right here. What's this height right here going to be? 6 3/8. From there, I can go down to my heel. How far of a drop? How do I find how far of a drop that is? I have a 6/12 slope, right? What's my run out here? 18. By cross multiplying and dividing there, okay, that's a 9-inch drop. So that's a 9-inch drop. I'm putting minus 9 inches. Nope. So we got 6 3/8, and I'm subtracting 9 from it. 6 3/8 minus 9. That's going to be negative, right? So we're going to flip that over. We're going to do 9 minus 6 3/8. I'm going to have to borrow from the 9s. That's an 8. And this will become, I don't know, I put a 6 there. That should be 8. So this would be 8/8. 8/8 minus 3/8 is 5/8. 8 minus 6 is 2. So this down here we are at a negative 2 5/8. We're 2 5/8 inches below the top of the wall. Does that make any sense? That subtraction with the fractions getting into a negative is kind of a bear. What that means is over here we're also at negative 2 5/8 inches. We're 2 5/8 inches below the top of the wall. So to get to our heel, we have to go back up to there. How far are we going up? Well, we have a 10-12 slope on an 18-inch run. Basically just this triangle here. If we cross multiply and divide, we get that this is 15 inches. So negative 2 5/8 plus 15 is 12 3/8 inches is that heel height. Now I'm going to show you a little trick here, by the way. When you're adjusting heel height, and this only works when you're adjusting heel height, you know these 2 points are going to be the same. This is 9 inches down. This is 15 inches up. This heel height's got to be... What's the difference between 9 and 15? 6. So this heel height's going to be 6 inches more than that, 12 3/8. It's a little shortcut. So that's if you have different slopes, but you're going to keep the same overhangs. And you're going to adjust the heel. This heel height here is 6 3/16 inches. 24-inch overhangs, 5/12 slope here, 12/12 slope there. Of course, fascias are going to match. Find that heel height there. In your notes, try to work that out. So, again, we start at this being 0 point. We go up 6 3/8. How far down are we going here? 10 inches, yes. It's 5 over 12 equals blank over 24. It ends up being 10 inches. So we are down here at 6 3/16 minus 10. This is a negative 5 13/16 inches, right? Three, you're right. 3. Sorry, I don't know where the 5 came from. Negative 3 13/16. Just keep it on your toes. I drew this wrong, actually. This should be drawn like this. To this point. So that means over here, we're also at negative 3 13/16. What height are we going back up here? It's a 12-12 slope and 24 inches. We are going to go up 24 inches. So that means that this is 20 and 3/16 inches. How many of you got 20 and 3/16? How many of you have no clue how I got 20 and 3/16? You got her now? Okay. So the next case we're going to use, we have different slopes. We're going to use common, I don't want to say common heels, but we're going to use standard heels. And what we're going to adjust is the overhang. This is actually used quite often. Can anybody guess why this would be used quite often? You can just cut the tails off. Yeah, you don't have to special order your trusses. To do this here, you've got to special order that truss with an extra high heel. In general, anytime your heel goes more than 12 inches, there's an extra charge. Depending on the truss company, but 12 inches was the companies I'd worked for. So I always put the lower slope on the left side just because that's easier for my little brain to wrap around. I'm used to working these left to right. And the lower slope is going to have the larger overhang. So let's say we've got 6/12 slope here and a 9/12 slope over here. This one we're going to go with 16-inch overhang. Want to know what this overhang is going to be. If we have a 6 3/8 inch heel here, and let's see here. This is a 6 13/16 inch heel here. So again, this is our 0 point here. We need to figure out how far down we're going to go to get to here. How far down is that? Well, it's 6/12 equals blank over 16. 6 times 16 divided by 12 is 8 inches. So that'd be 8 inches there, which puts us right here at a negative 1 5/8 inches. Yes? 6 3/8 minus 8. Or 8 minus 6 3/8 is 1 5/8. We're 1 5/8 inches below the top of the wall. So when we go over here, we know the 1 5/8 inches below, but we also already have the heel height. So what we actually have here is this total drop. Yeah, we add those up. And we have, what, 8 7/16, I believe, inches. So that total rise has to be 8 7/16 inches. Well, what are we going to do with that? We've got a 9/12 slope. That total rise of 8 7/16 over our overhang. So I've got parentheses 8 7/16 times 12 divided by 9, which is going to give us something really close to 12, 11.25. So our overhang is going to be 11 1/4 inches. So you trim all those tails back. What would you cut the tails to, by the way? Say 9 3/4. Why 9 3/4? When you build your tails, what's going to go out? Oops. What's going to go on the outside of your tails? Yeah, 2x6 subfascia. That subfascia is really what has to match up. So you cut them back an extra 1.5 inches. It's actually very common. They usually don't order them at 22.5 inches. They usually order them at 22 5/8 inches. So when you put the 2x6 fascia on it, subfascia on it, it's now at 24 1/8 inch. So they just cut all of their soffit at 2 feet and slam it up there, and they got an 1/8 inch to spare. Any questions on that one? Bless you. So, given this information, find this overhang. I'll pause and let you guys look for it. So, again, this is our 0 point. What is our drop from here to here? 6 inches. This is a 412 slope. We're looking at how much out of 18 that would be a 6-inch drop. So actually, we don't even fall below here. We're still at a positive 1/16 of an inch here, aren't we? Right? So we're still actually a 1/16 of an inch above here. Which means from here up to here is 7 inches. If that's 7 inches, then our slope of 10/12 equals 7 over that overhang. 12 times 7 is 84, divided by 10 is 8.4 inches. Oh, sure. Which is 8 3/8 inches, by the way. What do you think? Not so bad? How many of you had 8 3/8? How many have no idea how to get 8 3/8? The fact that that tail stays above the wall height is kind of screwed. Let's say we're going to have a common heel height on both. Same overhang. We're going to adjust the slope. I shouldn't even say same overhang, I should say set overhang, but So let's say that we're given on this side that this is a 7/12 slope. Then this heel height is a 6 9/16 inch heel. This overhang is 24 inches. We want this overhang at 18 inches. We want this to be 6 3/8 inch heel. So how would we do this? Well, this is our 0 point. How far do we drop to get from here to here? Well, it's a 7/12 slope over 24. That comes up to be 14 inches, yes? So that means we are 7 7/16 inches below the top of the wall. How far are we going to have to drop here? That's 13 13/16 inches. How do I get 13 13/16 here? Add those two. Very good. So now what? Well, I'm looking for my slope here. So it's going to be P over 12 equals my rise, 13 13/16 over my run of 18. .208 is what I get. My slope. So it's a 9.208 and 12. It's probably a 9.2 and 12 is what we'd run it as. What do you think? Yeah, this is a little backwards, yes. Okay, it is time for us to take a break. So we are going to do that now.